So you've got here and then an arrow and another point, and the arrow's longer, right?
And then it's longer than the last one.
Yeah, the last one, the longest. Okay. So this is, it has an initial velocity. Okay, so it starts with initial velocity. And this point is 0. So then it's asking x naught or y naught. So
And that's that, right?
that's this first point.
Okay.
So you can label these. You can say this is x naught, and then this one would be x1, x2, x3.
Okay.
And then these vectors, what are these vectors representing?
Well, that's.
Oh, actually, let's call this y naught, because it's all in y. Okay.
It doesn't represent their acceleration, their movement.
Yeah, it represents motion, but is it velocity or acceleration? These arrows.
I would say acceleration. I don't know if I'm right.
Not quite. So these ones are velocity. So it's saying that it covers this distance. Each point is at a certain amount of time. So I'll say frames every 1 second or every 2 seconds. So that means this point is at 1 second. So T1 or T naught equals 0. T1 equals 1 second. T2 equals 2 seconds. T3 equals 3 seconds. So then it's saying you covered this much distance in 1 second. So that's distance over time, which means it's going to be a velocity.
Okay.
So whenever you see arrows connecting points like this, it's always going to be a velocity.
Okay.
And then where would your acceleration vectors go?
They would go to the right of the graph.
Yeah, so you can draw them just off to the side, and they go right next to the point, because it's here the velocity is one value, and then here it's one value, but at this point it changes, right? Because this one is shorter than this one.
Yeah.
So that's how it's going to work.
I lost it.
So this would be A naught and A1.
Okay. So it's asking here if the quantities are positive, negative, or 0.
Okay, so each of these vectors has just some label. So let's see, x naught or y naught.
Yeah. So it's the first one.
Oh wait, let's see here. We want to look at this. The d, this is time 0, but if you look at our axis, that's the other important thing. You can draw your axis whichever way you want, but in this case they've drawn it this way. So positive y is this way, and this is 0 down here.
Okay. Because I put negative because it's going down.
So y naught is your position.
Mm-hmm.
So that's where your point is here in relation to your axis.
Uh-huh.
So where's this point in relation to this axis over here?
Oh, okay. So it's positive.
Yeah. And then this one?
Positive.
This one?
Positive.
And then this one would probably be 0. They've got it marked at 0.
Yeah.
So
Okay, so it has y0 and y1. Then it has v0y. What's that?
oh, hang on. So they've labeled it differently. So y naught is the top, and then y sub 1 is the bottom. Okay.
That's what we
sorry
did.
about that. Well, we marked it as y sub 3, right? So we went through four
okay.
different points. We labeled each point.
I labeled it y1 on the bottom.
Okay, so let's just do that. We'll get rid of these labels. So we have y naught at the top and y1 at the bottom. Okay.
Yeah, that's what I wanted.
So v naught, when it says or like this, it's just saying the x or the y just tells you whether or not you're going horizontally or vertically.
Okay.
So really you can just treat this as v naught or v naught. Like it's, you don't have to ignore you can ignore the x or the y. That's just
Okay.
telling you which direction it goes. That's typically how you would label it. So this would be v naught y, this would be v3y, but I think they labeled those differently as well. So let's see.
That makes sense for this one though, because I just put positive, but it's 0 because it's at 0.
Well, let's see here. Right, yeah. That's right. So it stops at 0.
Mm-hmm.
Then for the velocity, oh, okay, so you put positive for these ones. So the velocity at the top, V naught.
That's the first point?
Yep. So it's right here, and it tells you it's already moving down.
So if in velocity, does it matter whether it's going up or down?
Yeah.
Okay.
Yep. Because velocity is, so speed, it doesn't matter if it's going up or down, but velocity it does. Because velocity is a magnitude and a direction.
Okay. So that makes sense. So because it's going down, it's negative.
Yep. So it starts out going down, and then at the other one, V1, so at the bottom, which way is it? I mean, it'd still be going down, right?
Yeah.
So that'd still be negative.
Okay. That makes sense.
And then how can you tell the acceleration from your...
Well, the vectors are getting longer.
Mm-hmm. So you know that they're going longer in this direction. So your acceleration vector is going to look like one of these two. It'll be pointing down. So then you know that your acceleration is pointing down too.
So acceleration also is positive and negative.
Mm-hmm.
Okay, so then it's negative.
Because if you were... Well, actually, let's look at some of these other ones. Because this one's pretty straightforward. It's just like a ball falling out of a window or something like that.
Yeah.
It would always have a negative velocity because it's always moving down.
Uh-huh.
And it would always, up until it hit the ground, it would always have a positive position and a negative acceleration because we know that gravity accelerates it down. So this time I won't draw all that extra stuff on here. Oh, which other one? Which one would you say was like the most confusing for you? You didn't really.
Probably B.
Okay, so B, you've got, it starts over here, and then each vector is getting longer, right?
Uh-huh.
And it's starting from rest.
Yeah.
So this is, wherever they put, this is just kind of a notation thing for this book, is whichever direction they put the X or the Y means that's where the positive is. So they
Okay.
put X over here, that means going that way is positive.
Going that way is positive?
Yeah, so
So
this
that's
side
all
of 0
negative.
is positive, and this side of 0 is all negative.
Oh, okay.
So that's if, I mean, they could have, put numbers to it, like -1, -2, -3. That's kind of what they mean when they put the X. But you just have to watch for where they put the X or the Y, because that tells you which side is positive or negative.
Okay, I didn't know that. Okay, that's cool.
So it starts here, and then it goes this way. So when it starts, what's its position?
0?
Mm-hmm. And then when it finishes, is its position positive or negative?
Negative?
Yeah, because it's to the left of your 0. And you know the positive is that way, so over here is negative.
Okay.
And then at the beginning, what's its velocity?
It's -2, right? Because it's going down?
Yeah, so these velocities are all negative, but right at this point here,
Oh, it's 0.
yeah, it starts at 0. So it starts from rest. That's kind of what it means when it says it starts. So it's at 0, it wasn't moving, and then it started to speed up going this way.
Okay.
And then its velocity over here?
I don't know. Is it getting bigger? Or is it at 0 there too? Because it
Well,
doesn't say it stops.
Yeah, I mean, you have to kind of assume that they're continuing this type of motion. So it's not the best worded problem, but you just kind of have to go with it. But yeah, here it would continue to move to the left.
So is it the velocity is getting greater, but it's negative.
Mm-hmm.
So it's getting more negative,
Mhm.
right?
So it started out at 0, and then it started turning negative, and it got more and more and more negative. So here, velocity will still be negative.
Okay.
So you know that here it's 0 and here it's negative, and then what do you know about your acceleration for the whole thing?
Well, I guess it would be -2. That's so confusing though, because usually when you think of something as negative, it's getting smaller.
Right.
I guess that makes sense if you think
So
about it.
it's weird to think of a negative acceleration, because
Yeah.
you're like, wait a minute, it's going negative. It should be getting smaller, but it's actually speeding up. But it's important in physics. That's why you talk about velocity rather than speed, because a velocity has a direction. So it can be a negative number, you know. So you can be going this direction. Otherwise, you never know which way something is moving. If you always talked about stuff in terms of speed, so this has a speed of, say, it's 5 meters per second at this point. But if we just said it's moving at 5 meters per second, it could be moving at 5 meters per second this way, or it could be moving at 5 meters per second that way, or it could be moving at 5 meters per second this way. When we say a velocity instead, when we just say it's -5 meters per second, then we know that it's moving to the left along our number line. So that negative gives us the direction for our
Okay.
velocity. And then same thing with acceleration.
Okay. All right, that makes sense now. That was confusing.
And then one other thing that can be, I don't know if they have one like this on there, but let's just make a problem that's kind of like theirs, but a little more complicated. So let's put 0 here, make this positive x. So we start here. And then maybe it stops over here. So it's already moving here, and then it stops at that point. So here, what would your position be?
Negative,
Yep. And then at the end,
positive,
right, because you crossed the 0. And then here, what would your velocity be?
negative? Or is it going, because it's going in the positive direction?
Right, so it's positive. Even though your position's still negative, you know that your velocity is moving towards the positive side.
So position has more to do with where it's at, and velocity has
Mhm.
more with which direction it's going.
Exactly.
Oh my goodness, that's what everyone says.
Yeah.
So it makes sense, okay.
Yeah, and then acceleration has to do with which way velocity is moving. Like not really, but because velocity doesn't move, but which way velocity is changing. Because in this one, which would your acceleration be positive or negative?
Well, it's going down, so I think it's negative.
Yeah. Yeah, so you can just look at it and say, okay, I know that my acceleration vector will be pointing this way because each of my velocity vectors is getting shorter.
Yeah,
You can say, okay, it's gotta be negative.
okay.
And then you can flip it around, because that's another weird thing to think about, is if your velocity is this way, what's the sign for your velocity? And your axis looks like this.
What's the sign for the velocity?
Yeah. Is it positive or negative?
It's negative,
Mm-hmm. And what about acceleration?
negative as well. No, it's not positive, is it?
It is positive,
Dang
yeah.
it.
Because look here, this one is they're getting shorter again,
Uh-huh.
but you know that it's pointing this way, right? It's
Oh,
shorter
okay.
for velocity means this way. And you can kind of tell, so if velocity and acceleration have the same sign, whether it's positive or negative, then it's going to be speeding up, right, in that direction.
Okay, yeah.
But if they have opposite signs, then it's slowing down. So you know if you can
Okay.
see that it's slowing down, your velocity and your acceleration will have opposite signs. If you can see that it's speeding up, they'll have the same sign,
Okay.
whichever direction they're going.
I get it. So acceleration is which direction it is going, but not what the velocity is going.
No, the velocity is the direction that the particle would be moving, But acceleration points the way, it's kind of hard to explain, because like, it just tells you which way the velocity is changing. So here, if you kept having this acceleration, what would eventually happen?
It would stop.
And then, what would it do?
Go the opposite direction.
Yeah, so if every second you did the same thing, eventually you just hit a stop, and then you say, oh, well, we're gonna start going this way. So eventually the speed will turn and go the opposite direction. So that's just kind of how you have to watch for that.